Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the lecture number 5 of irrigation engineering. In this lecture we will cover these outlines. First we will have a brief revision of the previous 4 lectures which we have already covered. Then we will have the crop water requirement. Okay, the basic topic in the design of different irrigation engineering project, the planning and management of the irrigation project, which are depend on the crop water requirement. That is also called the consumptive use, or it is also called the evapotranspiration. Okay, so the water requirement of a specific crop at a given season is most important in the design, planning and management of any irrigation structure, and each and every crop have different water requirement, and also the yield of same crop at different moisture content availability in root zone is different. Okay, mean if you have the same crop but you have suppose planted it in different locality in different soil condition, then the water requirement will be different. And for example, if you have same soil, same locality, but the crop are different, again the water requirement for each and every crop will be different. So this is the most important parameter in irrigation engineering. So we will discuss the different methods, okay, the direct method and indirect method for the measurements of the crop water requirement at a specific area. Then we will have the irrigation efficiencies. Okay, basically crop water requirement is the actual utilization of water by the plants. So we have different types of efficiencies. For example, the storage efficiencies, the application efficiency, the conveyance efficiency. So when that efficiencies are accounted into the crop water requirement, so you will get the irrigation water requirement. Okay, make the difference between the crop water requirement and the irrigation water requirement. Okay, irrigation water requirement is the water required which you have to take out from a resource, the water which you have to divert from the reservoir. Okay, and the crop water requirement is the water which is favorably utilized by the plants, mean that is the actual demand, that is the actual requirement. Okay, so if you have to fulfill the crop water requirement, then you have to account the irrigation efficiency. For example, suppose if we explain it like this one, suppose if this is the ground surface, okay, and suppose that is the groundwater level. Clear? Suppose if you have to raise the water from lower level into the ground surface, okay, so that is called the edge. Okay, that is called the suction head, that is called the suction head. Suppose you are outing the this much discharge Q, so how much water will be applied on the water? Okay, how much power will be applied on the water to raise it from this one position to two position? So that is equal to gamma HQ. It means that if this much water is provided into water, then the water will raise from this one position into two position. Now see, we are applying the water with we are applying the power with the help of the pumps. So now the pump will apply favorably this much power. Now how much power you have to enter into the pump? So then you will have to account the efficiency of the pump. Clear? So that will be the power required for the pump, that will be equal to the power which is required, the power which will be actually applied to the water divided by the efficiency of the pump. Clear? Now here with pump we are installing a motor, so the motor will be favorably applying providing this much power into the pump. So how much electrical power will be provided into the motor, so that the motor may supply this much power into the water pump. So again here we will have to consider the efficiency of the motor. Okay, so how much electrical power will be required, how much input power will be required for the motor, so that will be equal to the power which is required for the pump divided by the efficiency of the motor. So then that will be the final power requirement. So if this much power is applied to the motor, this much power will be supplied into the pump, and this much power will be then applied on the water. So then it will be say that the water will be raised from one point to another point. For example, if this is the water power requirement, if this much power is applied on the motor, then here the power supplied by the pump will be less than this value and the water will not be raised. So in similar context, the crop water requirement will be less than the irrigation water requirement. Mean irrigation water requirement will be more than the crop water requirement, because we will have to account the different efficiencies. Okay, and then at the end we will have the assessment of the irrigation water, like the farmer are utilizing the irrigation water. So what will be how much amount of money will be charged into the farmer, how much they will have to pay. For example, mean iska it means that how much bill the farmer will have to pay. That is the assessment of the irrigation water. Okay, so first let's revise the previous lectures on the topic basis. Okay, so in lecture number 1, actually the course was introduced and the course information was discussed. Also the water resources, world water resources, Pakistan water resources, water budget of Pakistan, Indus water treaty, the availability and distribution of water both globally and regionally was discussed. Okay, also we have discussed in detail the irrigation engineering, function of irrigation, necessity of irrigation, scope of irrigation, engineering and agricultural aspect of irrigation, demerits and problems of irrigation. Okay, then in second lecture we have covered the types of irrigation, which are the flow irrigation or gravity irrigation and left irrigation, and also the method of irrigation were discussed, like surface method, sprinkler method and trickle irrigation method. Okay, then in the third lecture the component of irrigation system, for example the intake component, conveyance component, application component, distribution component was discussed, and also we have covered the irrigation water quality. Okay, that how the quality of the water will be assessed, what are the recommended parameters in the irrigation water, okay, which are defining the quality of the irrigation water, and also the basic terminologies like types of soil, preparation of land before the irrigation, classes and availability of soil water. Okay, limiting soil moisture condition, depth and frequency of irrigation, duty and delta. Okay, so all these parameters was discussed, like types of area, intensity of irrigation, Kharif Rabi ratio and factor affecting the duty. And then in the fourth lecture we have discussed some numerical problems related to the irrigation water quality, water depth in the root zone, duty and delta at different heads. Okay, at head of field, at head of water course, at head of the canal, and also the reservoir capacity. Now in this fifth lecture we will discuss the different methods for the measurement of the crop water requirements. Okay, the water requirement of a specific crop at a given season is most important. For example, here you can see that potato, maize, peas, every crop have different water utilization. So this water utilization, this water consumption is depend on the climatic condition, topographic condition, soil condition, types of crops. Okay, so these parameters will be considered. And also, for example, if the area is same, climate condition is same, soil is same, crop is same, but for example if you are applying the different amount of the irrigation water, then the yield of the same crop will be affected. Yeah, the yield will be different. Okay. So here in this lecture, first we will have some basic introductory points like evaporation, evapotranspiration, consumptive use, the factor affecting the evapotranspiration, potential evapotranspiration and actual evapotranspiration will be discussed. And then we will have some methods for the determination and measurement of the irrigation water, okay, which are the direct methods and the indirect methods. So every crop require a certain quantity of water after a certain fixed interval, okay, which also we have discussed in the previous lecture, mostly in lecture number 3. Okay, mean each and every crop we have to supply some sufficient amount of water at right time at fixed interval, which is also called the frequency of irrigation. Okay, so when that water will be required to supply, remember, when the natural availability of water is insufficient. Yeah, if the natural availability of water is irregular, yeah, the natural availability of water is variable. Okay, so then we will have to supply the water into the agricultural land by some artificial methods. Okay, and if the natural rainfall is sufficient, okay, so that it satisfy the water requirement, then no irrigation will be required. For example, in England, okay, the natural rainfall is regularly occurring throughout the year, mean there is no variation in term of time. Okay, so the water requirement for the particular crops of that area is satisfactory, so therefore no artificial supply is required. And for example, in our country like Pakistan, as we have discussed in our first chapter, water resources, that the rainfall is variable, okay, both in term of time and also in space. Okay, and also that amount is insufficient for the crop production. Okay, so we will have to supply the water to the crops by some artificial method, mean the rainfall in our country is irregular, that is not uniform both temporally and spatially. So the term crop water requirement, yeah, the water requirement of a crop means that the total quantity and the way in which a crop require water. Okay, mean how much water is actually required for the proper growth of a crop, that will be called the water requirement of a crop. Okay, and that is from the time of sowing to the time of harvesting, which we have discussed the crop period and the base period. Okay, so the water which a crop is demanding in its throughout period from the sowing to harvesting, that is called the water requirement of a crop. And our today lecture, the basic aim is that one, that how that amount will be determined, and that amount is vary the crop as well as with the place, mean for different crops that requirement will be different. And suppose if the crop is same, but if it is planted or cultivated at different places, then again that requirement will be different. And also the water requirement based on the climatic condition, most importantly. Suppose in a specific area, if the temperature is high, then the water requirement will be more, because evaporation and transpiration rate will be high. Types of soil, okay, for example, if the soil is more permeable, highly permeable, then deep percolation losses will be more. Okay, and you will have to apply or you will have to supply more water. Okay, also the methods of the irrigation and methods of cultivation, which we have discussed, like the surface in the surface irrigation, if you are applying the water, then more area are exposed into the atmosphere, so the evaporation losses will be more. Okay, and for example, the trickle irrigation system, the water is directly applied into the root zone, so in which the losses are less, so the demand of the water will be less, yeah, the supply of the water will be less. Okay, see here we have some basic crops. These are just the average values. For example, for the kharif crops, its growth period is from June to October, and the average water depth required is 42 centimeter. Okay, the rest of the properties are mostly the agricultural characteristics, that 1 hectare of land requires 15 kilogram of seed, okay, proper germination. But note one thing, for example, if this proper amount of water, mean that is the total water utilized in one season, okay, 45 centimeter, which is also called the delta. Okay, if this right amount of water is supplied to the crop at right time, then this will be the optimum yield, mean 3000 kilogram will be obtained from 1 hectare, mean that will be the average quantity, that will be the, we can say that the yield will be satisfactory. Okay, so for different crops these are the different water requirement. So the basic aim of our today lecture is to determine these value for each and every crop at a specified locality. Okay, and also here we will have the rabi crop. So these are the irrigation water requirement, that how much water is utilized by different crops in one season. Okay, and also we have discussed in detail at our third lecture that, for example, if a crop is sown and produced under absolutely identical condition, okay, suppose if you have a specific field and, for example, you divide this field into different plots, and in each plot, now see, the soil condition is uniform, okay, the field is same, so the climatic condition will be also approximately uniform. Now cultivate the same crop at each plot, and but provide the different amount of water into each crop. So see, the plot which get less amount of water, the yield will be less, and as the amount of water is more, then the yield will be more. Okay, so the amount of water at which you get the maximum yield, that is called the optimum moisture content. Okay, the yield increases with the water, reach a certain maximum value and then falls down, because after this limit, if you are providing more moisture content, then the pore spaces will be completely filled up with water and no aeration will be occur, yeah, no oxygen will be available for the chemical processes, and adversely the yield of the crops will be affected. Okay, the quantity of water at which the yield is maximum, that is called the optimum water depth. Okay, therefore the optimum utilization of irrigation, now see, this optimum water depth, this single moisture content cannot be provided throughout the season. So then we are taking a limit, yeah, we are taking some range, that the upper limit up to which the water is available in the root zone for the extraction, which is called the field capacity, and some lower limit beyond which the crop will be affected, mean that is the lower limit of the readily available water. Then we are considering this range, that if the moisture content is provided to the crop in between these two values throughout the season, then the crop yield will be optimum. Okay, the supply of water to the various crops should be adjusted in such a fashion as to get the optimum benefit ratio. Okay, and in that will be the readily available water from the field capacity to the lower limit of the readily available water. Now actually we are discussing two terms. One is the consumptive use and second one is the evapotranspiration. So in a specific area where you are growing the crops, suppose if here this area, for example, that is one crop, second, third, so there is some free space. Okay, so the water will be directly evaporated from this surface, yeah, the water will be directly converted into vapor state, which is called the evaporation. Okay, one is this phenomena, mean the direct conversion of the water from the earth's surface, yeah, from the water surface into the atmosphere, that is called the evaporation. And second one is that the water will be absorbed by the plant through roots. Okay, and that water will be moved to the leaves through its stems or trunks, and then that water will be evaporated into the atmosphere through stomata. So this is called the transpiration. Okay, this is called the transpiration and this is called the evaporation. Now the evaporation plus transpiration, that is called the evapotranspiration. Clear? And also some amount of water will be utilized by the plant during some chemicals reactions. Okay, during the breaking out of the food, or during the utilization of the food. Okay, so then the evapotranspiration plus that extra utilization, then it is called the consumptive use. Remember, when suppose 100% of water is utilized by a plant, so out of 100%, 99% is utilized by 99% is consumed by evapotranspiration. The rest of the 1% is utilized in other chemical reactions or other breaking of the food particles. Okay, so we can say that consumptive use is approximately equal to evapotranspiration, but in reality, in actuality, the consumptive use is greater than the evapotranspiration by 1 or 2%. Remember, the consumptive use for a particular crop may be defined as the total amount of water. Remember, the total amount of water used by the plant in transpiration and evaporation and other chemical reactions by utilization by other means, okay, in a specified time. So either the consumptive use will be on daily basis, okay, that how much water is utilized in one day, or the consumptive use will be on monthly basis, or the consumptive use will be on seasonal basis, or the consumptive use will be on yearly basis. The value of consumptive use may be different for different crops. Now see, for each and every crops the transpiration rate will be different, and different crops are grown in different season. So in different season the climatic condition will be different, so the evaporation rate and the transpiration rate will be different. So for different crops the consumptive use is different, and also the consumptive use is different for the same crop at different time and different place. For example, same crop, wheat. If wheat is cultivated in Peshawar and wheat is cultivated in other districts in northern parts, the crop requirement will be different. Okay, and also the time, with respect to the time, the consumptive use will be different. In fact, the consumptive use for a given crop at a given place may vary throughout the day. Okay, and also the consumptive use is variable with respect to time. For example, at daytime the transpiration and evaporation rate is high, so the consumption will be also high, and at night time the transpiration and evaporation rate is low, so the consumption will be also low. Okay, so there is also variation, monthly variation, seasonal variation, and yearly variation. So value of daily consumptive use or monthly consumptive use are generally determined for a given crop. Okay, and the basic aim of today's lecture is this one, that how that consumptive use will be determined. And after that, when the different efficiencies are accounted, like the conveyance efficiency, application efficiency, water use efficiency, water storage efficiency, if these efficiencies are accounted into the consumptive use, then we get the irrigation requirement. Okay, so that is the basic parameter in the design, planning and management of any irrigation structure. Okay, again we have different terminologies. Evaporation, that is the transfer of water from the liquid form into the vapor state. Okay, and the rate of evaporation from water surface is evaporation will be occur either from the water surface. Actually, on the earth surface, if there is water available, so it will act like a thin sheet of water. Okay, so then that water will be evaporated into the atmosphere. So what is the we can say that what is the vapor pressure at the air, and what is the vapor pressure at the surface of the water. So the difference between these two vapor pressures is responsible for the evaporation, and the evaporation rate is proportional to the difference between these two vapor pressure. Okay, so when irrigation water is applied by, for example, by flooded method, by surface irrigation, so large amount of water is evaporated. Okay, and that is a type of consumption, that this much water is consumed, this much water is utilized from the soil surface. Okay, second we have the transpiration, that is the process by which plant dissipate water from the surface or their leaves, stalks and trunks in the process of growth. When the plants are start to grow, so it extract the water from the root zone through roots, and then that water moves to the leaves. Okay, and then from the leaves through stomata, that water is evaporated, which is called the transpiration. Okay, and also at biological side, that is called the photosynthesis. Okay, as much as 99% of total water received by a plant through its root is lost to the atmosphere by this process. Mean the water which a plant is extracting from the root zone, so 99% of this water is transpirated. Okay, and the rest of 1% it is utilized in other functionality which is beneficial for the growth of the plants. Okay, another term which is used in the irrigation engineering, that is the transpiration ratio. Okay, so simply see, for example, if that is the earth surface in which you have grown different crops, okay, in which you have grown different crops. Now in the whole season, how much water is utilized by this crop? Okay, mean how much water is utilized, and when mean from the germination, yeah, from the plantation up to the harvesting, how much water is utilized, and when you harvest this plant, so how much dry product will be produced. Remember, excluding the roots. Okay, without the roots, if you harvest this product, okay, and dry it, so what will be the weight of that dry product? Okay, mean the weight of the dry product. So the ratio between the weight of the water utilized, okay, the weight of the water utilized divided by the weight of the dry product, but exclude of the roots, mean roots will be not included, so that is called the transpiration ratio. Okay, for example, if a crop, for example, in 1 square meter, suppose in 1 square meter, if a crop for example utilize 100 kilogram of water, okay, and from that 1 square meter of area, the dry product produced, okay, the dry weight of that plant is, for example, 0.5 kilogram, okay, 0.2 kilogram, for example. So then the transpiration ratio will be 500. Okay, so that is just the ratio, that how much water is utilized by per kg of the dry weight produced. Okay, so that will just indicate the consumption, that will just indicate the transpiration, that will just indicate the utilization of water. Okay, now we have different factors which affect the consumptive use, that why the consumptive use will be different for different area, for different crops at different climate, So first one is the evaporation. If the evaporation rate is high, yeah, if the it also depend on the humidity, so we can say that if for us from a specific area the evaporation rate is high, so automatically the consumption will be more, you will have to supply more water. Second one, the mean monthly temperature. Again, if the temperature of a specific area is high, so then the evaporation rate will be high, and again if evaporation rate is high, evapotranspiration rate is high, so the consumption will be more. Okay, growing season of a crop and cropping period. Okay, mean if a crop have more base period or crop period, mean if the crop is available for more period in the field, so automatically it will utilize, it will consume more water. Monthly precipitation in the area, mean that is actually related with the artificial supply. If in a specific area, suppose the natural availability of water is sufficient, then there will be no need for the artificial supply. Okay, so that is also depend, yeah, the artificial consumption of irrigation water is also depend on the natural availability of water. Okay, irrigation depth, or the depth of water applied for irrigation. For example, if you are applying more water, okay, so sufficient amount of water will be available and the consumption rate will be also high. Okay, and if the depth of irrigation is less, then the consumptive use will be less, but the growth or the yield will be affected. Wind velocity in the locality, again, if the in the given area, suppose the velocity of the wind is high, so automatically the dry power of the wind will be more, and the consumption, yeah, the water utilization will be we can say that more. Okay, soil and topography. Okay, different types of soil have different types of the characteristic, like permeability or storage characteristic or feed capacity. So different amount of water will be available. So if different amount of water is available at different soil condition, so automatically the consumptive use will be different. The irrigation practices and methods of irrigation, as we have discussed, like for surface irrigation, the evaporation rate is high. So if evaporation rate is high, automatically that amount will be counted to the utilization of the crops. Okay, so the efficient method will be used. And also we can say that the factor which affect the consumptive use can be classified into two categories. One is suppose the natural factor, and second is the management factor. Okay, mean that these factors can be controlled by the by human beings, and these are the natural factor. These factors are not in our control. So again, there in natural factor there is the climatic condition, there is the soil type, and there is the topography. So topography, soil type, and climatic condition, these are the natural condition which affect the consumptive use. In climatic condition, again there is suppose the wind movement, okay, the wind direction, wind speed, temperature, solar radiation, precipitation, humidity. Okay, these are the climatic factors. And in management practices, management factor, that is the amount of the water supply. Okay, so we can control that amount of water supply. The quality of the water, mean the water can be treated. Okay, the variety of the crop, the plant spacing, mean the space between the two plants, the irrigation scheduling. Okay, so these are the management factor which affect the consumptive use. Now we have two another parameters which is called the potential evapotranspiration and the actual evapotranspiration. Okay, so see, now as the evapotranspiration is clear, that the evaporation from the water surfaces or from the land surfaces and the transpiration from the leaves of the plants, that is called the evapotranspiration. Okay, so see, evapotranspiration is the total loss of water from land is evaporation, and from plant is transpiration. Now see, if sufficient amount of water is always available to completely meet the needs of the plant, then that evapotranspiration is called the potential evapotranspiration. Okay, it means that suppose that is the ground surface, here you have grown for example a crop, and for example at the root zone, if sufficient moisture content is available, if maximum moisture content is available, if proper moisture content is available, then the plant will extract the water easily. Okay, then the soil moisture tension will be less, mean the crop will easily extract the water, and the water utilization will be maximum, mean because if extraction is easy, then the transpiration rate will be high. Okay, so such evapotranspiration will be called the potential evapotranspiration. And see, when the water level is decreased, then the evapotranspiration will be not potential evapotranspiration, then it is called the real evapotranspiration, or it is called the actual evapotranspiration. Or simply we can also say that the evapotranspiration at any time is called the real evapotranspiration or the actual evapotranspiration. And when sufficient moisture content is available so that the water demand is completely satisfied, then the evapotranspiration at that time is called the potential evapotranspiration. For example, when the moisture content is at field capacity level, when the moisture content is at field capacity level, because beyond this level there is no water available, beyond this level the water will be drained out. Okay, so the evapotranspiration at that time will be equal to the potential evapotranspiration. Okay, mean because that is the maximum limit of the available water. This is the maximum limit of the available water. So the evapotranspiration at this time will be equal to the potential evapotranspiration. Also you can see that percentage of the available water. Okay, so percentage of the available water, for example, if it is 100%, so that will be the field capacity, because beyond the field capacity no water is retained in the root zone, mean it is drained out by the forces of gravity. Okay, so for example, that is the maximum percentage of available water. So you can see that the actual evapotranspiration and the potential evapotranspiration ratio is same, that is 1. Okay, because at that time the actual evapotranspiration and potential evapotranspiration will be same, so the ratio will be 1. Now as the plant utilize the water, then the availability of the moisture content will be reduced. So if the availability of the moisture content is reduced, then the actual evapotranspiration will be less than the potential evapotranspiration. So if actual evapotranspiration is less than the potential evapotranspiration, then what will happen? See, this ratio will be less. Okay, and a time will reach that when no water is available for the extraction. Yeah, if the plant is unable to furtherly extract the moisture content, then at that time the actual evapotranspiration will be equal to 0. Okay, see, potential evapotranspiration is fixed one value, but at that time the actual evapotranspiration will be 0, so the ratio between the actual evapotranspiration and potential evapotranspiration will also approximately become 0. Here you can see that the curve of two different types of soil, one is clay soil, second one is the sandy soil. So in the clay soil, more amount of moisture content is easily available as compared to the clay soil, because in clay soil the water is tightly attached, and we can say that the wilting coefficient of the clay soil is more than the sandy soil. Sandy soil the water can be easily extractable from the sandy soil as compared to the clay soil. Okay, now basically the basic aim of this lecture is this one, the measurement of the consumptive use. So basically we have two methods, one is called the direct measurement and second one is the indirect measurement. Okay, so in direct measurement we have 5 methods. One is called the tank and Lysimeter method, field experimental plot method, soil moisture studies, integration methods, inflow and outflow studies. Okay, so we will discuss one by one. The first one is the tank and Lysimeter method. Okay, so this method is more dependable than the tank and Lysimeter methods. It is a type of container. Here you can see in this figure a type of sample container, but it has some standard and recommended dimensions, that the surface area will be not less than 10 square meter. It can be greater than 10 square meter, but it will not less than 10 square meter. Okay, if it is greater than 10 square meter, so its determination will be more efficient. Okay, and the depth of the container will be, the standard and recommended depth of the container will be 3 meter. These are just recommendation. The depth can be variable for different types of crops, because some crops have shallow root zone depth, some crops have deep root zone depth, so this can be we can say that different, but the standard or recommended is 10 square meter surface area and 3 meter depth. Okay, and see, suppose you are finding out the consumptive use for this crop. Okay, so in which crop you are interested and in which area you are interested, as we have discussed that the consumptive use is different for different crops at different areas, so you will have to find out the consumptive use for the specific crop at a given area. Okay, so from the given area, fill that container, that tanks from the given soil, and cultivate the same plants or the same crops in that Lysimeter. Okay, now during irrigation, apply the water into the container and note it down with yourself. And remember, the bottom of the Lysimeter is almost porous, and sometimes a layer of coarse material or gravel material is placed in the Lysimeter. Okay, so the water which you are applying into the Lysimeter for the proper, for the optimum growth of the crops, we can say that sufficient amount of water will be always provided. So some amount of water will be drained out. Okay, now see, for example, you have applied one irrigation, then another irrigation, then another irrigation. Throughout the season, apply the irrigation into the Lysimeter. Now find out that how much water you have applied in irrigation minus how much water is drained out. Okay, so that will be the difference between these two, will be the water consumed by the crops. Okay, that how much water you have applied and how much water you have applied and how much water is drained out. So the difference between these two water will be actually the water which is utilized by the crops through evaporation and transpiration. Okay, so these are the experimental method, these are the direct method in which you have to measure the moisture content utilization or the consumptive use of different crops for the given area. Okay, so practically you have to measure these values. You have to note it down, these values, that suppose, for example, for the whole season you have applied 5 irrigation. So in each irrigation how much water you have applied, and in each irrigation how much water is drained out. So the difference between the total applied water and the drained water, that will be the total seasonal consumptive use per the given crop at a given area. Clear? Second method is the field experimental plot method. So in this method, suppose you have the given area or given field, so divide the given field into different plots. Okay, mean into different equal plots. Now see, the area is same, mean the soil condition will be uniform, the climatic condition will be also uniform, and in each plot, in each box, cultivate the same crop. So crop is same, soil condition is same, climate is uniform. Okay, now to one plot suppose apply 0 amount of water, to another block, for example, apply 5% of water, to another block, for example, apply 10% of water. So apply the different amount of water into each crops, into each plot. Okay, so that the losses may be almost 0, so that the runoff losses are almost 0 and the deep percolation losses are almost 0. Mean apply proper amount of water but different amount of water into different plots. Okay, now after the harvesting, when the crops when the crops grow fully and you start and you harvest it, then plot its moisture content versus the yield. Suppose what will be the yield of this plot which got 0 moisture content, is its yield will be 0, and the plot which got 5% moisture, so what is its yield? The next one. Okay, so plot these value. Okay, so if you plot these values, then see, if you plot these values, so you will get such type of curve. Mean, for example, to one plot to which you have applied 100% of water, mean which you have kept fully saturated throughout the season, again its yield will be almost 0. So the moisture content at which the yield is maximum, so this moisture content is applied to which block? For example, to this block. Now how much water you have supplied to this block throughout the season, that will be the consumptive use for the given crop at a given area in the given climatic condition. Okay, third number direct method is the soil moisture studies. Remember, this method is suited to those area where the soil is fairly uniform. Okay, when the soil surface is fairly uniform, the soil condition is uniform, and the groundwater level is too much below, so that it may not affect the root zone. Okay, means so that its fluctuation may not affect the moisture content at the root zone. So simply in this method, suppose you have applied the irrigation. So when you just apply the irrigation, determine the moisture content of the soil. So either you can find out by some sensor, or some soil sample will be taken from the root zone, and by gravimetric method, mean in the laboratory or drawing the sample in the oven, you can determine the moisture content. That when you just applied the irrigation, so determine the moisture content. Okay, now after 24 hours again measure the moisture content at that point. So see, the difference between the moisture content will be the consumption of the water. Yeah, that will be the water, for example, in millimeter utilized by the plants in one day. So that will be the daily consumption. Clear? So this is also one of the direct method that practically you have to measure it. Next method, direct method, is the integration method. So in this method, it is necessary to know the division of the total area. Okay, suppose that is the total area. So you have to know that how much area is under irrigation for the crops in which you are interested, how much area is under irrigation for the, suppose, vegetable, how much area is under irrigation for the extra weeds, yeah, unwanted plants, and how much area is open surface, yeah, how much area is the barren land. Okay, now the total water requirement for this area will be determined by the consumption of water by the crop plus consumption of water by vegetable plus consumption of water by weeds plus evaporation of water from the barren land. So that will be the total consumption of water per the given area. Okay, per the whole area. Similarly, the next method is the inflow and outflow method. So remember, this method is also called the annual consumptive use. Okay, and mostly this method is utilized for the large area. Suppose if you are finding out the consumptive use for the whole Peshawar district, okay, yeah, for the large areas on annual basis, that is also called the valley consumptive use. Mean if you are this method is used for the whole valley. Okay, yeah, on annual basis. So annual consumptive use, yeah, valley consumptive use. Okay, so see, for example, if that is the given area, so there are three possibility of entrance of water to this area. Clear? One is the direct inflow of water into the area, that is the surface inflow. Second one is the water inflow from the precipitation. Okay, and third possibility is the water from the ground surfaces. Clear? So actually in this method we are measuring that throughout the year how much water is entered into this area by some surface means, how much precipitation is occurred in that given area. Okay, now some amount will be also going out, some amount of water will be run out from that area. And suppose at 1st January what was the ground level, and at 31st December what is the ground level. So there will be the difference between the ground level. How much difference has been occurred in 1 year in the groundwater reservoirs. Okay, so see, the consumptive use will be equal to the amount of water which is entered into the area from the surface, the amount of precipitation which occurred in the valley, minus the run out water plus the change in groundwater reservoirs. Okay, mean the surface inflow plus precipitation plus change in the groundwater reservoir minus the run of water. Okay, so remember this method is recommended for the whole valley and for the annual determination. So that will be the volumes will be in acre feet, or that will be in hectare meter. Okay, because that is a large scale, so large scale units will be adopted. So this was all about the direct measurement of the consumptive use. But remember, these methods are time consuming, expensive, and the we can say that it take a lot of time to find out the consumptive use by these methods. Okay, so the lecture will be continued, and in next lecture we will discuss some empirical, mathematical, or we can say that some formulas will be utilized for the determination of the consumptive use. Thank you.